What happens if you fall into a black hole? Imagine you're an astronaut drifting through space. In front of you, a silent, massive, terrifying void. You feel yourself being pulled in. There's no turning back now. And what's about to happen will shatter everything you thought you knew about space, time, and reality. What is a black hole? A black hole isn't just emptiness. It's one of the most extreme entities in the universe. It forms when a massive star collapses under its own gravity. The remaining mass compresses into an infinitely dense and tiny point known as a singularity. Surrounding this point is an invisible boundary called the event horizon, the point of no return. Once you cross it, escape is impossible. Not even light can get out. In 2019, humanity saw the shadow of a black hole for the first time, thanks to the Event Horizon Telescope. A glowing ring of gas surrounded a dark center, proof that black holes are real, not just theory. They exist somewhere out there. The fall. What happens as you approach? As you fall toward a black hole, strange things begin to happen. Gravity isn't uniform. It becomes much stronger the closer you get. If your feet are leading, they'll feel a much stronger pull than your head. The difference becomes so extreme that your body stretches into a thin noodle. Scientists call this spaghettification. Physicists like Stephen Hawking explain it this way: the black hole's tidal forces pull and squeeze your body at the same time. You're torn apart down to your atoms. Not exactly a pleasant ending. Time distortion. Here's where it gets weirder. Time warps. According to Einstein's theory of general relativity, time slows down in regions of strong gravity. As you approach the black hole, time for you slows down relative to the outside universe. To someone watching from afar, you appear to move slower and slower, eventually freezing in place. Your image turns red, dims, and gradually fades. But for you, everything feels normal. Time ticks on. You keep falling, but around you, the universe rapidly ages. Stars move. Galaxies spin. Millions of years compress into mere seconds. Escape, is it possible? What about Hawking radiation? For a long time, scientists believed nothing could escape a black hole. Once you're in, you're gone forever. But then Stephen Hawking proposed a groundbreaking idea. Black holes can leak energy. This is called Hawking radiation. According to quantum physics, particle pairs constantly form and annihilate near the event horizon. Sometimes, one particle falls in while the other escapes, letting the black hole slowly lose mass. Over incredibly long periods, a black hole might evaporate completely. But don't get your hopes up. This process is unimaginably slow. A black hole with the mass of the Sun would take longer than the current age of the universe to vanish. So if you fall in, there's no coming back. What about supermassive black holes? Here's an interesting twist. If you fall into a small black hole, just a few times the mass of the Sun, you'd be torn apart long before reaching the event horizon. But if you're falling into a supermassive black hole, like Sagittarius A at the center of our galaxy, which is 4 million times the mass of the Sun, it might be different. Why? Because in larger black holes, the event horizon is much farther from the singularity. The change in gravity is gentler. You might not even notice crossing the event horizon. NASA simulations show a camera falling into Sagittarius A for hours without detecting the moment it crosses over. But once you're inside, space-time begins to drag you in. The singularity awaits. And when you reach it, everything ends. No warning. No escape. Fiction or reality? Wormholes? Other universes? Science fiction loves to imagine black holes as gateways to other dimensions, parallel universes, distant galaxies. And yes, mathematically, it's possible. Einstein's equations allow for wormholes, tunnels that bend spacetime. But to keep one open, you'd need exotic matter with negative energy. And we've never observed such matter in nature. Physicist Kip Thorne once said, "Nature may produce wormholes, but if it does, they collapse instantly." Some theories suggest black holes could spew matter elsewhere, or even birth new universes. But those ideas remain speculation. There's no evidence. For now, a black hole is a one-way door with no exit. So what really happens? The answer is simple. We don't know. Inside a black hole, our physics breaks down. General relativity and quantum mechanics, our best theories, contradict each other at the singularity. Some believe that one day we'll develop a theory of everything that unites them. Maybe then we'll understand what lies within. But for now, black holes remain one of the universe's greatest mysteries. One thing is certain. Black holes are real. They bend time, space, and reality. And falling into one is a journey with no return. So, if one day you find yourself being pulled toward that dark void, know this. For the universe, time may stop. But for you, it will keep flowing. And what lies on the other side? No one's ever come back to tell.